is the more complicated example, and I'm going to need to do a little bit of setup, and I'm going to have to move on to another slide to do the final parts of the calculation, because I'm not going to be able to fit it all on here. But I'm going to do my setup and my explanation here. So a student titrated 25 centimetre cubed portions of sulfuric acid. Okay, so this is the volume of my acid. Now notice that this is a volume in centimetres cubed. So that little section on our kind of grid that we lay ourselves out, where we convert from centimetres to decimeters, is going to be important. And we titrate that sulfuric acid with 0.15 mole per decimetre cubed sodium hydroxide solution. So that is a concentration. And that is a concentration of my alkali. The table below shows the student's results. So we have got the volume of the sodium hydroxide added, and we've got our titer table here. And then down at the bottom, this is really important, it says concordant results are those with 0.1 centimetre cubed of difference between each other. Okay, we're going to need that in a minute. The equation for the reaction is shown here. That's going to be really useful to us in just a moment. Calculate, there is our command word, using our bugs, boxing our command word. The concentration of the sulfuric acid. Use only the concordant results. Okay, so we've got to ignore the ones that are not within 0.1 centimetre cubed of each other. So those two are not within 0.1. We are only using these results here. These are the concordant results. And I'm going to calculate their average. Now their average is 21.13. Okay, now I am set up and I am ready to go with my calculation. So I'm going to move on to the next page and I'm going to show you how I would go about setting that up. Okay, so I'm going to start with the equation. 2NaOH plus H2SO4, and then I'm not really worried about the products here. I'm worried about these two parts. So they're the bits I'm going to leave for my table. Now remember, whenever we see titration, we go titration, calculations, very difficult, not really. So this is our concentration, our volume, turn it into decimeters cubed, it's our number of moles, and then it's our ratio. So from our question, we were able to look and see that the volume of sodium hydroxide that we added was an average of 21.13 centimeters cubed. But we want that in decimeters cubed, so I'm going to do divide by 1,000. Going from centimeters cubed to decimeters cubed, we divide by 1,000. So it's going to be 0.02113 decimeters cubed. Okay, I've got a volume. We also know that the concentration of our sodium hydroxide solution was 0.105. So I can put that into my table. Right, I'm nearly ready then. All I need to do now is have a little look, and it said in our question that we did 25 centimetre cubed portions of sulfuric acid. So I have 25 centimetres cubed, that's my volume. But again, I don't want it in centimetres cubed, I want it in decimeters cubed. So I'm going to divide it by 1,000. That's going to give me 0.025. That is my decimeters cubed. Okay, I know most about this left-hand side, so I'm going to work down this side, and then I'm going to work up this side. So to find my number of moles, I'm going to need my two equations. Concentration is the number of moles divided by the volume, and the number of moles is equal to concentration times volume. Again, just like before, I'm not going to just put the numbers in. I'm going to show the examiner I know what I'm doing. So I'm going to do 0.105 times by 0.02113. And that comes out as 0.0021. Okay. Now, the next important thing is I'm going to look at my ratio. So this is a 2-to-1 ratio. Now, going from 2 to 1, we divide by 2. So that's what I have to do here with my moles. I'm going to divide by 2. So if I have 0.0021 moles of sodium hydroxide, I've only got half as much sulfuric acid. So it's going to be 0.00105 moles. Right, we're nearly there. We've got our number of moles, we've got our volume. Again, I'm not just going to plug the numbers in and put the answer. I'm going to show the examiner I know what I'm doing. I'm going to do 0.00105 divided by 0.025, which comes out as 0.042 moles per decimeter cubed. So there is my answer. It takes a little bit of time, takes a little bit of practice, but these are often worth lots of marks in the exam, so it's well worth taking your time, practicing and remembering. Titration calculations, very difficult. Not really.